Hi, my name's Carol Lockhart and I'm with Woolpert, and I'm going to talk to you today about Bathy Lidar object detection and what's possible with the latest generation sensors. In 2018, we used a Chiroptera 4X sensor to conduct a high-resolution topo-Bathy Lidar survey to increase the navigational safety of Tonga and Niue. The survey was conducted as part of the IXBlue team for Land Information New Zealand, who in turn were doing this as part of the Pacific Regional Navigation Initiative. The goal of the PRNI is to allow safe and reliable passage through Pacific waters while protecting fragile ocean environments and allowing Pacific Island countries' economies to develop. The project used a combined sensor approach, with EOMAP providing satellite-derived bathymetry first, followed by Woolpert providing airborne LiDAR, and then IXBlue performing a multibeam survey. Overall, everyone involved found this to be a really great approach, with lots of benefits that could be discussed at length in a separate discussion. Today, I'm going to focus on some analyses we were able to conduct because we had such a large overlap between the LiDAR and multibeam. The LiDAR was acquired 4 to 5 months ahead of the multibeam and was planned to achieve hydrographic object detection to 20 meters depth, with multibeam performing object detection deeper than that. But the LiDAR was acquired to extinction in most locations, and the multibeam data came in shallower where it was safe to do so. This resulted in over 50 square kilometers of overlap, covering depth ranges from 5 meters to 45 meters. Since the LiDAR can survey shallow water more efficiently than the multibeam, we wanted to assess how reliable the LiDAR object detection was with a modern sensor. When conducting the object analysis, in the past this has been done by examining specific objects at the point cloud level. But this gives us tunnel vision almost immediately and can lead to us focusing on differences that don't really matter to the final product. It's also very difficult to scale this approach to large areas. Therefore, we wanted to do the analysis on the chart product or a proxy for that product, since at the end of the day, it's those differences that really matter to the mariner. For the analyses, we used a proxy for the largest production chart scale. We then used focal statistics to interrogate the LiDAR and multibeam final bathymetric surfaces, taking into account that largest chart scale. This process identified where the chart would end up being different between the two technologies. Once we had our difference locations, the first thing we did was assess them to see if there was any depth correlation, but we didn't find any. Likewise, we were curious if environment type made a difference. Again, we didn't find any strong correlation. Across the overlap area, we found 71 grid cells where multibeam identified something, where LiDAR had no correlating object. We also found 76 grid cells where the LiDAR identified something and multibeam had no correlating object. However, over 12.5 million grid cells agreed. In other words, we achieved 99.999% matching in the overlap areas. Let's look more closely at a few representative examples in the point clouds. Here, the multibeam in red clearly detects the object. If we look only at the LiDAR data for the same location, we see that the LiDAR detected the object, but the data on top of the object is flagged as rejected. This is an editing error. We also saw examples of this in reverse where multibeam was flagged as rejected. In this example, it appears that the object is represented correctly both by the multibeam and LiDAR point clouds. However, if we look at the multibeam surface, it isn't pulled up to the shoal as sounding. This was the most common error we saw and highlights the importance of knowing the largest scale for which the surface will be used, since the surface is what's passed on for charting purposes. There are techniques we can use to highlight these potential issues at a given scale before finalizing the surface for delivery, but the scale has to be known. During the editing phase for this project, the final product scale hadn't been decided by LINS. This was their first time using this approach, and they wanted to understand what they could achieve first, which is understandable. On future surveys, I would expect this to be less of an issue, and therefore it would drastically reduce the number of surface representation issues. So in conclusion, we need to make a distinction between object detection and object recognition. In most cases, the sensors detected the objects, but they weren't always recognized during editing as such. There were editing mistakes in both LiDAR and multibeam because there's still a human factor present in processing of these complex data sets. As discussed already, scale matters. I like to think of map once used many times as really being survey once, map many times. Once we have the raw data, we can process and classify it very differently depending on the required project scale and purpose, with potentially very different levels of effort required. To that end, although not discussed here, seabed reflectance data, orthorectified image mosaics, and topo LiDAR were collected simultaneously with the Bathy LiDAR, and all of this data was processed and delivered for multi-purpose use by the local stakeholders, not just for updating of the nautical charts. I think it's important to remember that the analysis showed the success rate here was very high, and likely would be higher if product scale had been available during processing, as it would have reduced many of the surface representation issues which caused the majority of the differences we saw. And lastly, the combined project approach was very successful to help achieve the goals of PRNI. If we use the right tool at the right time, in the right location, we can survey more efficiently and effectively. And this analysis showed us that the LiDAR was the right tool to provide efficient high-resolution surveys in these types of environments. Thank you for your time. I really appreciate it. I hope you found this interesting.